Okay, so hello everyone. Welcome to this last problem solving session of this course, C Programming and Assembly Language, NOC 24 CS 128. So it's week 4 and okay, so very less people are there. So just confirm, am I audible? Just thumbs up or raising hand can work. I'm also opening the Q&A. Okay, thanks. So Q&A is open now and um one more thing, the internet connectivity here is a little bad today, so there may be some disruptions, so please bear with me. I am pausing the video, and whenever there is some disruption in sound or anything, just write on the Q&A. I will try to do the needful. Okay, so let's get started for the problem solving session. So this week was all about how this printf works and what are some security threats, and also if I say how the local and global variables are stored, and at last the summary of overall course. So I will not go deeper in that. I will go by the questions, and in that questions also I will try to actually explain the things which were remained in the last some sessions, and the previous year questions also today we will solve. So we have around 20 to 25 questions to solve today. And additionally, if needed, I will go through some theory if there will be need, only then. Okay. So there are too many things to cover. I am starting the session now. If someone will join, if there will be some problem, I am just writing it on the discussion. If someone joins late and there is some problem or issue, just write on this Q&A. Okay, it will be there for good. Okay. Okay, so I am starting the session. Uh, okay. So we will start from this program. I am opening it for it's 7:04 till 7:07. This screen will be there for you. You just write it down, the code and the assembly code, because from question 1 to 7 we will solve using this only. Okay. So we are having this code. Till then, I am just giving you a brief introduction about what is happening in this code. So you also write it down somewhere because we will use it. So sorry. Uh, the statement is like given below is a C code along with its compiled assembly output. Analyze the following and answer question 1 to 7 based on it. Values in red are missing and need to be identified by you. Okay, so we are having multiple values from V1 to I think V9, and we have to solve it through different questions. And okay, so there are two things. There is a C code and there is a compiled assembly code. Let me change the color so that you may not get confused. Okay, so we have int C decal area and int Y turns X into Y. Okay, this is one thing. And in int main, we are taking a variable a where we are storing the area, but the problem is we are having four arguments, and we will be using only two because given independence to use two, but we are taking four arguments here. So can anyone just write on the discussion what kind of warning it can provide or error it may give? It is covered in the lectures. It will be good if there will be some erroneous sentences, no problem. You just write. Sorry. Just try to write something which is covered in the lectures. It was in lecture 16, I think, where sir has told what kind of warning or error will be given if you provide more arguments or less arguments. So sir told there are two kind of problems. If I see the lectures, there is two things, passing fewer arguments or passing more arguments. Can someone answer this? There's something on chat? No. Okay, so the warning will be given. Okay, there will be warning if there will be fewer arguments, there will be compiler error, and if there will be more arguments, then there may be warning like too many actual parameters provided. Okay, so there will be warning. Oh my God. Okay, so there may be warning. Okay, it changed that too many arguments provided. Okay, so with this warning, the code will get executed and it will take uh, the values 4 and 2 and provide the answer. Okay, that one thing will happen. Uh, there are some compilers, those may not give the warning that may result in error, but in case of MSVC, what is considered for the course, there will be warning. Second thing is there is index that is for statement recognition only. Then there is we have this compiled assembly code. There we are having area proc where we are pushing EBP first, then we will move ESP to EBP. Okay, then we have taken this EAX and we take 32-bit pointer from EBP and we then multiply it with the value stored at EBP plus V2, and then we pop out EBP, that is the calculation we have got, and then we return it. That is end of the program. Then in main function, we actually again push the EBP. Actually, we will start from main only. when the function will be called, then we will go to that area proc. Then EBP, ESP conversion. Then there is a counter. Then we will push the values. These are values, those are responsible for this 4273. I have told in a previous problem we have discussed in the last lecture. And then there is call area, which will call the area function, and we will start adding to stack pointer. Then we will move EAX to the D word pointer. Then we will clear EAX. Okay, so that will happen, and EBP will be moved to ESP. Then we will again take out the EBP and we will return the value, and then end of program. This is overall thing in the code. This kind of, I think, surface area problem we have solved in the last lecture. I had drawn overall flow of that instruction pipeline, how it works. So you can take reference from there. We have done something like this. We can do something like this here also. So I think you have noted it down. Uh, am I audible? Because there is no response. Okay, thanks. Okay, so I think you have noted it down. So let me proceed for the questions. So we are having first one. Observing the compiled assembly output, the values of V3, V4, V5, and V6 respectively are. So I want the answer from your side. We are having these four. Let me erase the other things. We are having these four, and we have to provide the value of V3, V4, V5, and V6. Can someone write the answer? Then we will discuss further. 3, 7, 2, and 4 respectively. Yes, good, Raj. So in the last lecture also I uh, told how to solve it. We actually go in this direction. Okay, when we push like this. Okay, so we will start pushing. V6 will take then V4, V5. So we go in left to right direction. So it will take 3, 7, 2, and 4. So 3 will be there in V3, 7, okay, like this. So the answer will be, I think, B. Okay, good. What does the above C code return after execution? It's a very simple one. Please answer. Good. So I already told it. The program will be executed, although there may be error. There may be warning, not error, in case of MSVC, but it will run and it will take first two arguments. So what will happen here if I just draw this scenario? Say we will be having something like this. We will be having local variable, then main, then um, there will be 3, 7, 2, 4. Then there will be return address. Okay. And after return address, we go to ABP main. Okay. And after that, there will be local variable space. So from here, it will take value of x is equal to 2, sorry, 4. And from here, it will take value of y is equal to 2. And rest 2 will be remained and given warning for that. So 4 and 2 will go there and it will execute it, return x into y. So 4 into 2 will be 8. So answer is 8 here. Okay, coming to the next one. Based on passing parameters between functions, what are the values of v1 and v2 respectively? Can someone answer this? So v1, v2, if I see, it is here. One where we will store x and next is where we are storing y, which will be multiplied. Good. 8 and 12 respectively. Yes. So those who are not getting, if we go with that stack implementation only, so there is 3, 7, 2, and 4. So after that, there is return address. Like here, we move EBP, then EBP ESP, then we have these four, then we have call area, and call area will return some address, and then we will go to this space. So EBP main, and then there will be local variable space. So what will happen? EBP will be pointing there. Then there will be a return address. Okay, that will take to 4. This now this return address will take 4 bytes. So we will be having ABP plus 8, and then we are having integer. So it will also take 4 byte. It will be having value ABP plus 12. Okay, and stack pointer will be somewhere here. Okay, so what we wanted, we wanted this x and this y. Sorry. So x will be accessed with EBP plus 8 and y will be accessed with EBP plus 12. Okay, and in question, what in the code there is EBP plus v1 and EBP plus v2. So v1 will be 8, v2 will be 4. Sorry, 12. So what is the option? Option C is correct. Now, based on the calling convention used to call the function area, so in C code, what will be the value of v7? Can someone answer it? I want some other answers. Raj has given one. Is there some other options or answers? Good. Sai and Raj, very good. So there will be 16. So how it will be. Let's see. So we are having V7. We have to add this to stack pointer means what we will have to do. We will have to take the control from here up to here. So we are having four variables. Okay. And we have to go 4 bytes because we are having integers. So we have to move from this ABP, uh, say from this space to this space, and we are having four variables which are occupied, and we have to clean up after that return address. So 4 into 4, total 16 will be. Uh, we will have to actually uh, the addresses we have to access. So V7 will be 16. Okay. Now, coming to the fifth one. If the calling convention of function area was CDCL or STD call, then value of V8. There may be more than one option correct. So you have to tell what will be there in standard call, sorry, and what will be there in CDCL. So what will be the answer? Can someone comment? Hmm. No, exactly. It's not the exact answer. Think again. For standard call, it's correct, but for CDCL, it's incorrect. So what happens in this provided assembly code? The value V8 refers to return value from area function, and that will be stored in EX register. So in both kind of calls, the return value of function will be stored in EX only. Hmm? Yep. So if we go to this compiled assembly code for output area, the multiplication will be taking this IML EAX, say IML EAX, and there is keyword pointer, and the result will be stored in EAX only. So the return instruction, that is this return V8, means the return value is placed in EX, and no stack cleanup is required in CDECL because the caller cleans up the stack. Okay, so if I write for we there are stack cleaners in case of STD call, and in case of CDECL, in case of STD call, there will be the calling function, okay, not the caller. And in case of CDECL, there is the caller function, not the callee. Okay, and the address order in this case is left to right, and there is right to left. Okay, so if we use such convention, so no stack cleanup is required because the caller cleans up the stack. So in this case, V8 will be 0 because no additional stack adjustment are necessary for returning from function. Okay, I'm writing the reason. So V8 will be 0 for CDECL because no additional stack adjustments are necessary for returning from the function. Okay, what will happen here? Uh, the caller, or we can say the main function, will handle the stack cleanup. Okay, in CDECL, it will happen like this. But in case of standard call, STD call, the callee function, that is the function being called, is responsible for cleaning up the stack after function returns. Okay, so in case of STD call, there is callee function, means the function being called, the function being called is responsible for cleaning up the stack after the function returns. So this differs from CDECL, where caller cleans up the stack. So in this assembly code, uh, when we will go for return V8 in the area function, that will be important because in STD call, the return instruction would include an immediate value to clean up the argument that are pushed onto the stack. Okay, so this value represents the number of bytes of arguments passed to the function. Okay, so I am writing it in standard call. Um, this return instruction would include an immediate value to clean up the arguments pushed onto the stack, and this value this value represents the number of bytes of arguments passed to the function. Okay, so in area function there are two arguments, x and y, both are integers. Since integers are 4 byte in this cross 86 architecture, so the total argument size what it will be? So there will be 4 bytes for X and plus 4 bytes for Y. So total it will be 8 bytes. Okay, so therefore we can say value of V8 will be 8 because byte needs to be cleaned up and that will happen from stack when the function returns. Okay, so it will return 8 in case of this. So the answer will be in a standard call there is V8 is equal to 8 and CDECL there is V8 is equal to 0. I can say A and D are the correct options. Is there any doubt? Okay, I am just pausing it here for 1 minute so that if someone want to just write it down. It's 7:32 till 7:33 it will be there. Till then, please comment the value of V9, what it will be. Good. Because cleanup doesn't occur at main. That is default in CDECL. So will not happen inside the function. So it will return 0. Okay. So it will be 0 because cleanup doesn't occur at the main. Mm, in case of CDECL, and so it doesn't happen inside function, so it will return 0. So I can write the values V1, V2, V3, V4, V5, V6, V7, V8, and V9. So V1 we have 8 and 12. V3, 3, 7, 2, and 4. V7 and V8. V7 is 16. V8 is either 0 or 8. V9 is 0. Okay, so this big question is solved. Now coming to the this seventh one, the last one, according to that. Assembly statement 18 correspond to which C statement in above C code? So assembly statement 18, that is called area, and we want C statement for this. Good, because it is calling the area function, so control will is actually passed from here. We have taken the local variable and then we call the function. So what we can say that area function for so area function is called in statement 18, that is equivalent to A is equal to area, the parameters given. So that is statement 8. Answer is D. Okay. So now coming to this one, this is the myprintf uh, function which was actually discussed. Uh, it's a basic version of that. That is it is discussed in lectures, and it's a basic version of that. So uh, it's 7:37. I am giving you 5 minutes till I am just explaining what is happening in this code, and then what we will do, we will actually go through this the next 8 to 16 questions based upon this function. You just write it down somewhere. I am just zooming it. So there are two things, FMT and AP. So in context of C programming, FMT and AP commonly appear in say variadic functions, where function that can take variable number of arguments. So FMT is actually kind of placeholder for format string. Its typical use in the function is that it takes variable number of arguments to specify how the arguments should be formatted or we can say processed. Okay, and the common example that is provided in the lectures is printf style family of instructions. So there the first argument is format string that contains placeholder like %d, %s, etc. Okay, so in case of printf, we can take format string that specifies how to format the argument that follow it. Okay, so %d and %s provides a format, and there is another thing named argument pointer. Okay, so argument pointer is used in conjunction with the VA list type to traverse the list of arguments in that variadic function. Okay, so it is initialized with the VA start, and it sets it to point to the first argument after the named arguments. Okay, so uh, after that it is used to access additional argument in the function. So in case of variadic functions, we actually use FMT and AP together. So format string specifies how arguments should be interpreted or formatted. Argument pointer is used to iterate through the arguments in the function, retrieving for each one in turn based on expected types of format string. Okay, so together these are used in function like printf, scanf, or custom variadic functions to handle flexible number of arguments in controlled and type safe way. Okay, so in this code, what is happening? We are having stdio.h, stdr.h. These are header files, you all know. So there is a myprintf char fmt instruction, sorry, function. So it is myprintf function, and there is character array and there is a character pointer. There is VA list of argument pointer. There is int ival, there is double D value, there is char s value, and then we call VA start of argument pointer and format string. And then for this format specifier, we actually take, if it is percent, we will put this character P, and then we will continue. Again, we will go for this P, and we will check if it is after percent, if there is D, if there is F, or if there is S. If there is D, we will take number of uh, say format specifiers and the values corresponding to that, and we will print that. If there is D val, if there is F, we will take double. Okay, and we have 1.2 F. If there is S val or a string, we will take like this. We will iterate over all the words in that array, say string, in that string. So, and then we will put it. And after that, we will break. In default, if there is p percent something, we will put the character and then break, and then there is return. And then there is a void main function. So, return 0 means it is telling that code is executed properly, and it will clear up the stack. And then there is my printf function is called, where there is, we have to print check, then percent s will take the argument from this, after this comma, then integer, then percent d, then there is fraction, then percent f, and that will be printed. So this is overall code, and based upon this we will answer the next some questions. So I'm providing 2 more minutes. If someone hasn't written it, just write it. It's 7:43. We have a lot of time. So just write it for 2 more minutes, then we will dive into the question. Till then, let me see the discussion forum questions if there is something in the discussion forum. NOC 128. CS 128. Okay, I cannot actually go through this year's assignment, so I'm really sorry for that. We are not instructed to do this year questions. Yes, Sai Kumar. Okay, yes, you can rejoin. Till then, I am just going through the discussion forum questions. If I can solve something for you, most of this Vamsi Krishna is, I think, done, and just the things which are related to this year's assignments, we are not instructed to take questions on that. C and C++, for submitting assignment, I cannot help. It is difference between C and C++. C is the basic one. C++ has some advanced things, and you can search it on Google anyway. There are multiple things which can be done using C++ that is not actually inbuilt in C. It can be hard coded for C, but present in this C++. So, okay, in the video of first lecture, there was some data bus and address bus which were given from microprocessor to RAM. So that is shown basically how the address is passed, and I have covered it in my first problem solving session. So and rest join button C coding. Okay, that is also done. Doubt in practice zero. I cannot solve that. Okay, I think most of you have got answers from their dedicated TAs. So, and rest, which they haven't answered, are also not instructed for us to do. So, I think all of the problems are actually taken up, which can be solved by me. Okay, so I can clarify that I'm not given instruction to solve this year questions. Um, yes, Raj, I got your question. There was problem in this assignment for question number 14 and 15. So I cannot help. Sorry for that because it's for, I think, this year questions. So I cannot go for that. We are instructed not to do anything for current year. I am taking this previous year assignments. So if there is something which is related to the this year assignment, then you can just put the question in this meeting. And if you are getting multiple answers, there may be a chance if you are right, then there may be a chance that there may be misprinting or anything. Uh, the question you are asking for So hidden integer key inside the function. Let me read it minus. Permission you were given for uh, there is function that take integers. Okay, then they have applied some function on it. Argument passed to a function addressed by VP plus 8 and local variable is minus 4 onwards. Okay, and undefined elements in stack pre-initialized to this. Stack is analyzed right after function call to define this, which is the hidden integer key defined inside function. Okay, so if I say the approach, you should first analyze the function like there is fx given for ax plus b, and then you can formulate the equation, and then uh, you can subtract it. What is this telling? Analyzed and right to after get two different outputs. So like arguments are given from EBP plus 8 and local variables that is in traditional way, and there is undefined stack elements, those are given. So if you say you can just extract the values like converting it to say hexadecimal, or then or you can say in the decimal values, and then set up the transform and solve the equation, and based upon that just analyze the things. That is what we can do in simple ways. There is one question more I will solve. I get constant a and b, but I don't know. Let's treat up as hidden key. So Uh, in my opinion, what I could suggest is that if there is something sensitive, like uh, in one question, we will do something like that. Uh, if there is, say, we are having some condition on something, and there may be, there is like if-else branching. So there will be condition on something, or there will be default something. So default is not sensitive. That is like a default thing which can be accessed without any manipulation or anything. So if you get the idea, like if there is you think that is sensitive one, or that can be transformed throughout the loop or the time in the stack when we apply the equations, then that will be key for sure. And if the information that is calculated that is not sensitive, then that is not need to be hidden. I think you got like the sensitive one you can treat is as a hidden key. The non-sensitive you can leave. And if there is multiple options, then that is good. If there is one option, then you should just think about what is the more sensitive one that you should consider as a hidden key. Okay, Raj, I can help like till this only. So you can solve, just put the values and apply the linear transformation which is given. Uh, Skip the inputs and uppermost stack. Everything is almost constant. Okay, that's thing. mm, So in that case, you should identify the relevant stack value. Uh, so for example, if I say there are some inputs and your uppermost stack values like you have given. So that will be actually result of something. So we can uh, just consider something like suppose the function performs that linear transformation that is given and compares it to a key. And then for the inputs given, we are getting like that. So we should substitute and we should get some values based upon the we will get some linear functions we can get, and based upon that we should calculate the values, and from there we can extract the keys, like reverse approach, if I tell it in brief words. Go for reverse engineering. Okay, try. um Otherwise I think the solutions will be posted maybe by their dedicated TAs. Yeah, yeah, I think I should clear my statement. With that into consideration, hidden keys. Yeah, hidden keys. Uh, if you go through cryptography, keys will be constant, but the values that is encoded that may get sensitive. Uh, For any other source, you can just go through basics of cryptography. I think that will help. Basics of cryptography contains this kind of questions where you actually apply some hash or some kind of salt value to encrypt the functions. That will help. Yeah, I think that will help for sure. And I am correcting my statement for that. Uh, the key maybe you can say constant, but the value we are getting that may be you can say sensitive for after applying that function. That happens in for different cases. You may have different things. Okay, so solve it. Let me complete it once. Then, if we will get some time, we will extend the overall things again. Yeah. So it's a kind of a good question, but it's I will say this is the lengthy one rather than a complex one. So, what data types can above function myprintf handle correctly? Can someone answer? It's a very simple thing. I am waiting for the answers. Percent D, percent F, percent S. Yes. If you see, there are three cases. Okay, we have percent D, percent F, and percent S. So percent S, we have this one, and percent C is not there anywhere. Okay, so this are correct. So A, C, D are correct ones. Now, answer the following based on execution of C statement 42. C statement 42. Like we have my printf this. If I just zoom it, what will be the answer? If this get executed, what will be uh what will be printed? Can someone write? It's mm, yeah. How many times does the statement 30 gets executed? Okay. There is statement 30, this one. Okay. So statement 30 is this as well. How many times it will get executed? Can someone answer me? Very simple one. Just focus on the this my printf statement and you can answer it. Just try. Wrong answers will also work instead of just uh, being idle. Raj and Sai Kumar has given most of the answers. There are other person, Anita, Lisa, Pavitra, D, Divya, MN Bimal, Gunavati, Doleswar, Sandhya, Shiv Kumar. Guys, just write something, write some answer. Okay. The hint is you are given this string. Okay. So for any percent s, in case of any string, so you have to just parse this thing. Based upon this, you can answer. Not three, not three. Just see, there is this string. Okay. And for S case, we will start this AP and char pointer. So we will start from first one and we will actually increase it till its end. Okay. So no, UF is another thing. UF is another thing. Just go by this. This string is within inverted comma. We will fetch using this, and because there is no specifier for that, percent UF is not a specifier. 6. Yes, till 0 it will run. So 1, 2, 3, 4, 5, 6. Answer will be 6 here. Yeah. I well after execution of statement 21. So what is statement 21? This one is 21. I val is variable argument, AP and int. So if we will get this integer, we will go through corresponding pool of the values, and we got this integer. Okay, that will went through ival. We have got var. We have accessed the integer. So ival will be storing this one. So the answer will be, what will be the answer? Simply 2. Okay. In case of string, it will go through case of s. If there is f, that will go for case of double. In case of this integer, it will go for ival. Now, coming to statement 10 of the above C program, translate to the following statement: LEA EAX divert pointer EBP plus V1, move divert pointer EBP plus V2, comma EX. So it loads first divert pointer to EAX and then move EX to divert pointer, and statement 10. Statement 10 is VA start FM. Okay. So if we start, so AP will start from -8, pointer will start from -4, and FMT will start from 8. So when it will run, it will start from EBP. What? EBP plus 4 plus 8, and it will be EBP plus 4 minus 8. So value of V1 will be 8 plus 4, it is 12, and V2 will be 8 minus 4, it is 4. Okay. Minus 8 plus 4 will be minus minus minus. Now it's what is printed after execution of C code. So there is check. Yes, good Raj. So there is check statement. Check percent s. Percent s will start from string. Check string. In percent d, there will be 2. Fraction percent f. Percent f is taking 0.678. Okay. So 0.678, there is 1.2%. So there will be only two things. Okay. So 1.68, and there is percent UF. So that will be there. as UF only because that is not a specifier that is given. So if we start check string, that is correct in all four, integer 2 correct in all four, fraction 1.2, so 1.678 was there, so 678 will be rounded off to 68 only. Okay, 678 was there, so it will be rounded off to 68. So these two may be correct, and percent UF will not go to 4 because there is no specifier such that this. So answer is C here. Answer will be C, not this because there is 0.2f. 0.2f means we are taking only after two places of decimal. So this will get uh, rounded off. Okay, so answer will be C. Now, in this code below, note that 142 present in C variable. A needs to be secure from one unwanted access. Answer 14 to 16 based upon following C code. So let's start from there. We are given this function and intent, and what will be printed when this code will be executed. So let's val is will be printed. That's we have to provide function of 1. So a is 1. No. If the function is given as 1, if n is 1, it will be executed. So it will return a into 7 plus 3. So 142 into 7 plus 3. What it will be? 4, 9, and 199 plus 3. So val is 997. Option B is correct here. Next question is upon execution of statement 11 of above C code, is the value 142 in C variable A secure? Okay, C variable A for value 142 for statement 11. It is function of 1. That's what I was telling earlier. Yeah, good. So if we are taking function of 1, function of 1 is sensitive because there is a formula that will run on A. Instead of that, if it is not 1, it will go to else statement, that is A is 0. That is constant value. But here it is encoded. So that's why it is a more sensitive information we want. Yeah, stack cleanup will not be done. Okay. So that's why it can be accessed if stack snapshot is taken after statement 11 executes. If we change it to function 2, we change it to function 2, it will go to else statement and it will actually clean up the things. So yes, now change to 0. There is nothing to be care about more. Okay, so that is like the previous year questions. Sorry, previous year questions on this week. So now I will go for the questions which were remained in previous weeks, and I promised to complete it. Okay, so we have now 45 minutes. I am taking 3 minutes break. Till then, if there is some doubt about what I have covered today till now, then please let me know. Okay, so no questions. So let's go for the previous week questions. So it was, I think, week one question where we were given, say, the following 7 bytes are stored in the extra segment with address of last element 81 stored at start address, and the address is increasing as you go up the list from bottom up. Consider the following program to search 47. So what we will do in such kind of questions, let me uh, go with the better approach to solve it. So if we go in this way, um, we are having this move AL. So what it will do, uh, there is a value that is, I think, in hexadecimal, maybe. Sorry, that is loaded to AL register, and this will be the value that this SCASB will be searching for. Okay, so AL is having 47, and this statement will search for it. Then there we have EDI, data index register is loaded with this start address. Okay, which point to the last element, that is 81. Okay. Then next is we are having this ECX, that is the, you can say, kind of a counter register that is loaded with 7, and it indicates that there are 7 bytes to search through from start address upwards. Okay. Then there is CLD, that is for clear direction flag. So DF is equal to 0 for that, ensuring that scan proceeds forward from low address to high address. Okay. Now there is RIP any SCASB. So it will repeat the scanning uh, of the byte at address EDI for the value in AL. Okay. It continues until either AL is that byte at EDI, or ECX or counter gets 0, or 0 flag is set. Okay. So what it will do, it can do three things. Either, sorry. So if you know the answer, you can write. I am just solving because I promised in the last session. So it will be going good if it founds uh, the condition, it matches the condition AL is equal to byte at EDI, or ECX gets 0, or 0 flag gets set. Okay. So the data we are given is something like this. If we write something like this, or we can go with this also: 96, 16, 47, 74, 81. So when we will execute this repeat non equal to not equal to SCSB, then the scan will start from start address, that is this, which contains value 81, and proceed upwards through the memory like this. Okay, or here like this. For each comparison, ADI is incremented because clear direction sets direction flag to go forwards, and EDI will increment and ECX will be decremented. and the program searches for the value 47 and stop when it will find it. Okay, so if we perform the step one by one, first value scanned is 81. Okay, as start address. So no match. So ECX is decremented. Okay, ECX minus 1, or we can say 6. It was earlier, ECX was 7. Now, next value is 74. So again, not found. ECX will be decremented to 5. Next value is 47. Okay, match found. Hmm. So the search stops here because 47 is found. At this point, ECX would have been decremented 3 times. So the match was found after scanning 3 elements: 81, 74, and 47. Okay, so ECX will be ECX minus 3, that is 7 minus 3, that will be 4. So answer will be 4 here. Okay, you are facing. I actually answered it earlier. I cannot help directly in this question because this is this year's assignment question. So we are strictly uh, instructed that we cannot help directly for the questions. For the time being, I can say that you may go through some basic cryptography tutorials or numericals where hash functions are used, and you can just take the values, apply the linear transformations, and get what sensitive values you are getting. Okay, these are actually in hexadecimals. Convert it into decimal or apply the equation that is given in the assignment, and get the encoded values decoded, and then come to some kind of conclusion based upon that. That is what I can help, and rest all the things, I think weekly solutions will be uploaded by the dedicated TAs, and these will be solved in next year's PMRF session. Okay. Yeah. Thanks, Sai Kumar, for asking. Okay, so it was 4. Next is this was also remained because I was not able to go through in week 1 assignment. So in this case, what was happening is just a second. So what is happening here? There is STD, so DF will be set to 1. AL is set to 14. ECX is set to 9, and EDI. Okay, no problem. So EDI is set to 0x0216. So if any CSB is applied, like in previous question, we will do same it again. So we are having this one. Okay. And we are actually searching for 14. Okay. So, so we will start from here. We will again go through this. We will again go through this. So we are having 9. So we will go to 8, then 7. Okay. And it was first comparison, it was second comparison, it was third comparison. So 9 minus 3 comparisons were there. So there will be 6 as the answer. Okay. So answer is 6, or you can say A. So in these kind of questions, you should consider that the third one where we have got the actual value for which we have applied this as CASB, scanning the string, we should also consider that the thing we have actually got in the last one, which is actually found as the match of the string which is stored in AL, is also a comparison, and then subtract, or we can just add it plus 1. So like 8 to 7, 7 to the last comparison was 14. So answer will be 6 here. Again, um, value stored at EDI after code snippet executes. So there was two comparison. First comparison took it to this value, second to this value, and after this, for sixth comparison, means for ECX 7 to 6, it will go one up. So that will be A2913. So if we are going from this 0 to 16, 0 to 16, we will go to 0 to 15, 0 to 14, so 9, 7, 9, 8, 7, and for 6 it will be 0 to 13. Okay, so this will be the answer. Answer will be A here. Now coming to the next one, what can we say? The direction flag was already set to 1 with STD, so it will be B only. Now coming to this one was actually done, but there was some confusion. That's why I told to do it again. This was actually the Fibonacci one. Okay, so before going to this, I want to answer these two questions because these are not having that kind of problem which was there. These are actually based upon some code execution only, uh, as per I think. So let's say for this one, uh, one thing I clarify that the code is for Fibonacci series. Okay, so for this question 5 to be K, I think we should start from very beginning only. Okay, let's start from the previous one, from fourth one. Otherwise, there will be some problem. We will get. So we are given this function. We are having neg operand that replaces the operand which is 2's complement, and there is operand is general purpose register or a memory location. Okay, so we are given a code uh, where we have inline assembly code within the C code. So if we start analyzing the code, we are having first instruction. So here what will happen? ECX will be 8 as the loop counter. That is n because it is n minus 1. Okay. And there EBX is F0 is 0. Then there is F1 having EX. EX will be 1. And inside the loop, what will happen? We have to, there is loop. Okay. It will run till it ECX does not having value 0. Okay. So what is happening here? We are actually adding EAX with EAX plus EBX. Then we are having EBX. We are doing it EBX minus EAX. Then we are actually taking neg of this. So I can just write it like minus EBX, or in bracket I am just mentioning it's 2's complement of EBX. Okay. And then we are actually decrementing ECX by 1. Okay. Jump if not 0 means it will run till it's not equal to 0. Okay. Now in loop iteration, what will happen? What will happen here? Let me change the color. Hmm. So what will be happening here? In first iteration, in initial values, we have this EBX is 0, EAX is equal to 1. Okay. So in first iteration, we will be adding EAX with EBX. Okay. From X, we will add. Okay. So EAX will be 1 now. Then we will subtract EBX, EAX with EBX. So EBX will be now minus 1. Then we will take neg of this. So EBX will be 1 and ECX is decremented and it will be 7. Now coming to second iteration, what will happen? EAX is again added with the EBX. Okay, so it will be 1 plus 1. Okay, because we have taken neg of EBX, so it will be 2. Then EBX will be having 1 minus 2, again minus 1. Then neg of EBX, it will be taking minus of minus 1, it will be 1. And ACX, again ACX will be decremented to 6. And so you can see 1, 2. Again in third iteration, what will happen? ECX will be decremented to 5. EAX will be 2 plus 1, 3. EBX will be 1 minus 3 minus 2. And EBX will be having neg of this, and ECX will be 5. Again in fourth iteration will be EAX, that will be 5. EBX will be 2 minus 5. 2 minus 5 is equal to minus 3. EBX neg will lead it to 3. ECX will decrement to 4. Here also again in fifth, sixth, seventh, we will go like this, and in eighth iteration, it will actually come like EAX will be 21 plus 13 if you will solve 34. EBX will be minus 21. EBX neg will provide 21. Actually, if you will take 2's complement or we just take neg, that will not actually do that much problem for us. So can go likewise. Cx is that will be 0. So after eighth iteration, if it reaches statement 14, so Fn is actually taking value of Eax. So eighth iteration will be done. This will come out of loop, and finally, we will get the statement as 34. Ex is 34 here. Okay. So I am writing it like 1, like 2. Again, if the instruction were executing on 32-bit processor, what is the largest value one can assign to n in statement 3 such that program reaches statement 14 without overflow of the accumulator in statement 9. Okay, so overflow means we should provide something which is actually uh, not getting too much digits that is not stored. So in that case, uh, if I went through the previous year assignments, how they did, they actually went through the code, and from there they just analyzed the values they can get. So actually there is a value of decimal, this decimal value of 4294. I'm just writing it. You can just go through it with your calculator or anything. This is the overall decimal value which can be stored. So we have to provide value of n, or we can say the nth element of Fibonacci, which is actually just lesser than this. After that element, it may overflow. So they actually proceeded with the Fibonacci of 47 and Fibonacci of 48. So 48 was actually 480752696, which is actually greater than this. Okay, so we just came one level uh, down. So we got 297.121.5073. So from there we got that Fibonacci of 47 is the one which will not overflow. Okay, so that's why the answer was 47 here. And let answer 5 to be k. It is 47. Now apply n is equal to 5 in statement 3. What is statement 3? It is n is equal to 5. And by n is equal to k, what will the value of Ex? So we solved it, and we got this value 5702887. Okay, just apply the formula and you will get like that. Okay, so that is the overall thing that was happened. So all the questions which I wanted to discuss, I actually discussed till now. So there are 19 minutes left. If there is any question someone want to ask, they can ask. I'm giving you 4 minutes. Uh, then I will just summarize the overall course from first to this week, what we have done, and then we will wind up the overall session. And just muting my mic for 4 minutes. Just think, and if there is some question, just write on the discussion box. Okay, so no questions till now. So, uh, what I noticed is that uh, I just went through the previous year videos I have uploaded. Sorry, previous week videos. So, the things you are asking in the chat box that is not actually visible as a statement in that videos. So, but I have, I think, recited everything, so there may be no problem. So those who will be just watching this video of this session, just get informed that there is a Q&A part, which is kind of chat discussion, and the student put their questions there, like these students are giving, and they post answer there. So based upon that, I am just reciting the things and taking the questions. Okay. So okay, let's just debrief everything. So today we went through this question where we were given a program of calculating area, and we went through all the values, how the stack is constructed, how the values is given and assigned, and values are given and assigned, and then there is uh, how V1, V2 and all parameters are calculated. I also told in brief what are the stack cleaners in case of STD call and STD, sorry, CDECL underscore. Okay, and there is cleanup and all the things. Then there was a function where was uh, my printf was given, and that my printf is actually was able to scan all the things except %c based upon the implementation, and it run uh, based upon the format specifier given, and based upon that it accesses the value. Then there was security based question. So if it is not actually attacking the sensitive part, there is no problem. Then there is the previous week question. I think it was from week 1. It was remained where we were using SCASB. I think in last 4-5 minutes, I will just tell something about SCASB and all these kind of statements, because I think that was not properly covered in the first lecture because it was too basic. So I wasn't able to cover all the things. Then there was another question. In both of the questions, we were having something like we have to scan and compare. If we get the answer, we will stop. Okay, and we will just update the data index and the counter based upon that. Okay. One more thing, there was this thing 8 to 9, and we are using equivalent 0 2. Okay. And then there is week 2 question. It was, I think, where I told to come with the proper example that I tried today. Okay. So, and these two questions are basically you can do it with your calculators. And so there is all the things I wanted to cover based upon the questions. Now I am just telling something about the instructions which we actually use in this cross matrix. Okay, so first is scan string byte SCASB. So it actually compares the byte at the addresses specified by EDI register with the byte in AL register. Okay, so if they are equal, it updates zero flag. If EDI register is incremented or decremented based upon DIR flag. Okay, and the syntax is CASB, and example is if AL contains say 41 ASCII value of EDI register points to memory location of byte 41. SCA will be set Z flag, zero flag, if comparison is successful. Then there is compare string byte CMPSB. So it actually compares the byte at address specified by ESI, stack index. Okay. Uh, so um, so it is actually with the byte at the address specified by EDI register, and then we can say it updates the flag on the comparison results. So if say ESI is pointing to B, or you can say 0 cross 42, and EDI again points to this, so compare will set 0 flag if the two bytes are equal. Then there is move string byte, move SB. So move SB is used to move a byte from address specified by ESI register to the address specified by EDI register. Okay, so ESI points to some uh, byte and EDI points to destination, and based upon that, sorry, SI is source and DI destination, you can say, registers. So it will copy 055 or any bit from source SI to destination DI. Okay. Then there is REP, repeat while equal. So it repeats all the say commands or the statements until 0 flag is set. Okay. Uh, and it will be set when uh, the things will get equal. Then there is REPNE, repeat not equal to. So we have seen it in case of SCASB also. So till it will not get equal, it will not set the 0 flag and it will run. Then there are word pointers. There is D word pointer. So word pointer is for specifying that operand is a word and is having 16 bits. Okay, and D word pointer is of 32 bits. And one more thing, that if we will perform multiplication, that can be performed in various instructions. So most common is mul and imul. So when we will go through mul, we will be using the register which is having more capacity, because if we are multiplying say 8-bit numbers and we are storing it in AL and BL, then the result should be stored in AX, because the output may be of 16-bit. And if we have signed bit, we should use imul. Okay, and in both case, if the product exceeds the storage capacity of the result register, it will overflow, and you may need to handle the overflow or use larger registers, say EAX or EBX, or 32-bit operations to avoid the overflow issues. Okay, so I think these things I wasn't able to cover in the last lectures. So that is all from my side for today. If there is any doubt, we have 5 minutes, around 5 minutes left. So if there is something to ask, you are welcome. So in this course, we actually learned how inline assembly code works. From week 1, if I start, we went through assembly instructions and we got that we should use this MSVC for better use of this inline assembly codes. And there we thought about, we got some information about this, some assembly codes, some assembly program commands. And then in second week, we went for some of the instructions, some of the programs, how it will be stored. In third week, we went through all the things which were left, like how we can store the local and global variables. And then in the last week, we went through how to use this printf and all this kind of commands, how it gets accessed. And in third week, we also went for the compilers, how it works, how there may be some errors. And this week, we actually went for any kind of warning we can get, like if there is too much values we provide, we may get warning, we may get error also, but that basically depends upon the compiler we are using, how it is coded. So in compiler we have lex and yak, YACC, which actually takes care of lexical analysis and then semantic analysis. So we actually go through, you can go through that compiler design course also for better understanding of that, how it happens and how it is coded. So in compiler, what happens? We actually take the code, we actually first parse it for lexical analysis, where we actually take the overall statements, and these statements are converted in kind of tokens. Then these tokens are actually parsed using some syntax and semantic analysis phases, which actually tells that whether the syntax are actually correct according to that language or not. Then the semantics, like rules, how these are, like we are given %d comma something, and then we put semicolon after each statement in C. So that is checked in that phase. Then there is a error correcting phase. Then there is intermediate code generation phase, where we get some intermediate code which can be deployed in any kind of other machine hardwares. And then target code generation, that is done in which may be done in same machine or in different machine. And then at last, there may be code optimizations based upon the compilers used, like we have done in second week content. And at last we get the final assembly code, or we can say executable. Okay, that is actually if you like, if you generally use GCC, you get the file .c and you just compile it using GCC compiler. You get some a.out by default, or some name.out object file which actually runs. That is executable one. Okay, that is object file, and we actually execute that object file to get the things done what we want. So that is done through compiler. If there is error, there are different errors or warnings. Warnings are something which will be given like a statement, but that will not affect the execution of program. The program will get executed. There may be some wrong answers, but the program will get executed. That will depend totally upon the compiler, how it takes. But in case of the other thing, if there is error based upon the compiler program, then it will not execute. And sorry, if there is some fewer statements we have, then again we will get error by default, because the stack either will have garbage value or will not have anything. So that will also take care about. And in security purpose, like in last lecture, it was covered. We may have different security algorithms to encode all the things, and uh, what we try to do is that we want, after execution, the stack should be totally emptied, so that if someone takes snapshot of that stack, the information may not get sacrificed or compromised. Okay, so based upon that, the security part is done. So we actually want to encode or just delete the information which is of very sensitive use, and that should be just erased after execution of local variable, say function, local variable in a function, or the function itself. Okay. So that is all for this course. Thank you all for joining. Thank you all these three person which are there for me, I think, or maybe left. So thank you for joining. You may leave, and I am ending the meeting. This was all about this course. Thank you. Thank you, Anand, Pavitra, and D, who is D. Thank you.